Thank you guys, everyone, so much for joining. As always, this is the Graph Builders Office Hours. My name is Kevin Jones. I'm a developer relations engineer at Edge and Node, working on the graph. And yeah, we're really excited to have Thomas on today from the BuildersDAO. Thomas is super skilled, and basically we're going to be recording this as always. So just be mindful of that. This will go on YouTube. So just keep that in mind. Thomas, I think you've been on here before, but I don't think you need an introduction. Everyone, this is Thomas. Did you want to share your screen? Basically the floor is yours. So
we could jump right into it. So last time I did a demo, we had some feedback of, hey, I'd love to see more about SPS and Substream subgraphs. And I thought it was a good idea as well, because there's not too much stuff on the forefront as far as that area goes. So today I'll just be walking through what is kind of happening on the Substream side. When you're developing Substream powered subgraph, what are some things you need to identify, some things you need to keep in mind, because it is different. Rust itself has somewhat of a higher learning curve, but when you're used to just writing subgraphs, there's some things that you may be looking to do when you're writing Substream powered subgraph, and you have to kind of make up little tricks here and there as you go. So I'll showcase some of that stuff and really show you how easy it is to actually go from a Substream to subgraph. So I will share my screen. First thing I'm going to do is I'm going to use the wonderful Substream's init command and just spin up an entire Substream from just feeding a contract address. So we'll pick, I don't know, let's do GRT. Get the contract address on mainnet. Do substreams in it. We'll name this, SPS office hours demo. I'm going to select Ethereum, mainnet. I'll put in the GRT contract address. And I demoed this. I demoed this in the last video somewhat. Really what's happening is the Substream CLI is generating a Substream template for us. So it goes to the block explorer. It gets to the ABI. It takes the events from the ABI and converts them into modules. And then you could then use that data whichever way you wish. So I'll have this finish up. All right. So let's go into that directory. All right. So now we have the full project structure here. So a couple of things are automatically created for you, which is great when it comes to SPSs. What I like to do when I'm developing substreams is to use the init command as my base. It gets all the events automatically from me, and then I'll transform them if I need to, and then I'll do a output to the graph. So when we first come in here, you're going to see the substreams manifest, and you have all your modules here. And there's these entity changes here. So this is very important. This is essentially how the substream is going to communicate with the with GraphNode. Okay. So these entity changes are exactly that, right? When you go into Subgraph, you'll see all your entities that are being emitted. This is to convert the Substream data into a specific entity of the subgraph, okay? So if you're doing this from scratch and you're not going to use the init, it's important that you use this package. You import this package to get those types. All right. And then another thing that is kind of like the default module name for outputting to the graph is this graph out module. All right. And it's a map module. So it's going to output some data. And the output is of the type entity changes. So this is exactly why we needed this earlier above. Now, it's taking an input of all the events, and then it's outputting them as entity changes. So we're going to dive into that area of the code. Let me just change my tool chain. So we'll go into source, go to the lib, and the graph out module right here, okay? So it's creating a variable called tables, and it's an entity changes table. So you have to start thinking in a tabular structure of each table is for a given. Each table is for a given entity, right? And we're creating something that's mutable and has all the tables stored within it, okay? So it's going to be a table of all the entity changes. And then it's passing it into this graph out function. So when we come in here, we can see a bunch of different things it's iterating over. We have the approval events. We have the minter adds, the minter removed, the new ownership, new pending ownership, and the transfers, okay? So let's just jump into the transfers. And you could see here that we have a tables that we passed into the function that we created down here. And now we're going to create a row in that table. And the table name is your entity name. So whatever you have in the schema should be matching that name, all right? So when you go and load a entity in a subgraph, when you're coding it, and you say, hey, load this specific entity, this is essentially referring to that. So we have the create row with the name. And in this case, this entity is called GRT_transfer. And then you have the key. So this is going to be the ID of the entity. All right. So it's completely up to you to set those things the same way you would in a subgraph. All right. And then you have a little chaining going on here. So you have on this row, I want to set this value to this, right? So this dot set takes two inputs here. It takes the name, which is the field name, and then the value is the actual value of that field. Now, one thing to keep in mind is that you could see there's no explicitly stating what the data type is, okay? So you have to know these things inherently as you're coding this out. So you will list each one. So now, in addition, the init command will create a schema file for you, okay? Which you're going to need just as if you would need it for a subgraph. So the entity are all listed here, same way it would be in a subgraph. And if we go to the GRT_transfer, we have ID, event transaction hash, event index, event block time, event block number, from, to, and value, right? Just like you would in a subgraph. So this is going to explicitly state the type, just as it always would. But it's important that when you pass it into the lib file, you're going to have to make sure that that type is matching. So for this transaction hash, it's of type string, as we could see here. It has to match, or else when we actually push this out to the graph, it's going to fail. block time is going to be most likely a big int, I would think. Or even block number, right? Is a U64. Okay. So we have all that being said here. Now, this, like I said, creates it nice and easy for you, but sometimes you're not going to just want one-for-one parsing of the events. You want to do some data manipulation. So once you have that done on the Substream side, you would do the same thing. We would just, if there was a new field here, we would just do .set, make the new name, whatever it is, and then we would pull in that value. Okay. Some things to keep in mind when you're dealing with these tables. One of those things is that we're doing a create row here, right? So it's going to create a new entity. But let's say you have events that are coming in where you want to update an entity that already has been admitted, right? So let's say for this transfer, we somehow have the same transfer hash and we want to aggregate to it, let's say. You could do tables. Now we have multiple things that we could do with tables. We have create row, delete row, and update row. So we would do an update. So you would do the same thing as GRT transfer. We'll put in that same ID key. And you would just set a single given value. So let's say the from is being updated. You do from and whatever that new value is, okay? So I know in Subgraphs, you would go load the entity. You would have access to the Subgraph store. And you would then say, okay, give me this entity. Now you have all the data of that specific entity, like the last update of it. And you would say, okay, just update this one value and then save. So this is comparable to that, right? One thing that's a downfall is that you don't have access to the whatever you admitted before. Remember, this is just streaming the data out. So you don't have access to that specific, to the whatever copy is currently the latest, let's say. So you have to manipulate Substreams in a way where you're going to have to use the built-in store and kind of use that in your code. Rather than, in a subgraph, it's very easy to just, hey, go get the latest version of this entity. I have it. Now let me update this one value and then admit it. Here, you don't have to explicitly load anything, which is nice. But if you need whatever you previously written, you're going to have to do that yourself manually within the Substream. So we also have delete, right? So that's pretty self-explanatory as well. Delete row, table and key. What that'll do is that'll just delete that entity from that point going forward, right? So the structure is the same. You're going to put the table name, and then you're going to put the key that you'd like to delete from that table, all right? So again, the big thing when you're dealing with Substream powered subgraphs, at least in my time with it, is that you have to come up with creative ways of using the Substream store, acting as if it was the store that you have access to when you're writing subgraphs. And it becomes a little trivial sometimes and a little tricky. Not to say that you can't do it, but it's one thing that you're going to have to keep in mind. To me, that's like one of the biggest differences between when you're working between the two. So you have the create row, update row, delete row. This is just create a new entity, update an existing entity, and then delete an existing entity. When you're dealing with the updates, good to keep in mind that you could just pass in the single value you're trying to update, right? create, you should have everything there that you need for that's required in the schema. Another nice feature is when we do the set. So if I do tables, and then we do a set here, you can see we have multiple ways of setting, right? So we have set big decimal, set big int, and then set big int or 0. So set will not infer type for you. Remember, I said before, there's no type. You have to make sure that your types are matching the schema that you're going to actually publish up. These other functions here that are big decimal or big int will take the value of a string from whichever mat module you're importing into this and convert it to that type. So you don't have to do the type conversion in the Substream. You could just, if I'm doing set big int on a string, I would just do set big int and keep it moving. That way I don't have to worry about any of those data conversions in this. Sometimes you'll need to do the data conversion, sometimes you won't, but these are nice little shortcuts that I really like to using as I build out my Substream powered sub. So what we'll do now is we'll actually deploy this up, right? So we'll go to the studio. Create a new subgraph. We'll name it, BuildersDAO demo. Okay, so now we have our we have everything necessary to get this deployed. And we're going to do the same steps as we usually do. We don't have to do any of this other stuff if you don't have the CLI installed, obviously. The init we don't have to do because most of the files are already there for you. So we're going to take the CLI command. We'll come over to the project here and run that. We'll come back. You don't need to do any code gen. Already there. I think that you have to create, at least on Windows, I'm not too sure how it is on other. You have to create a builds folder here. It will error out. So we'll do a graph builds. I forgot a step. All right. So before you actually deploy it up, you have to create a package, right? You have to pack up your substream. So we had our base substream already created, and I'm going to just do make pack. And what that's going to do is create this SPKG file. And we'll kind of step through what's actually necessary. Hold on. All right. So now we have this SPKG file. Now, if we look at the subgraph manifest here, it already has that file name already put in for you. But this is what the subgraph manifest is going to look like. All right. We have the description. We have a path to the schema file, and then we have a data source of substreams, the name, the network. We have the package. Right, so the source is the package, which has the module name of graph out, which we just went over. and then the file that's the actual substream, which is in our directory right here, FTU packet. And then the mapping is the graph entities that we discussed. So now we can run the graph. We can run graph builds. All right, great. And then we could just deploy it. All right. Look at that. See, we're already up. We're syncing. We'll probably have some entity changes coming in soon. We'll check them in a second. But what's going on in the background now is if we thanks, James, for showing me this one. So what we're going to do is we're going to run the Substream's GUI on the graph out module and see what's actually being emitted, right? So if we go to graph out, go into the output, and we can see here we have an array of entity changes, okay? And we have an entity name. So this is all being done on the fly based on it being of that type of entity. Now, we have the entity name, all right? So in our subgraph, we're going to see GRT underscore transfer. We have the ID of that. We have the operation of create. So if we did an update, it would say update. If we did delete, it would say delete. And then all array of fields of each of those values, all right? So we have the block time to the value of the transfer, the transaction hash, and the event index. So as we continue on, you can see even more. Here's a minter being added, right? And we have all those entity changes. So this is the way it's communicating to the subgraph to get the indexation done. These are being outputted, and that's what these are those table changes that we made. And it's taking all this data and then syncing it right up to the graph. So if we come back here, let's see if we got anything flowing yet. Go to transactions or transfers, say GRT transfers. It does camel case it instead of the underscoring. It automatically does that as well. This value to from, let's see if we got anything. There we go. So we got transfers coming in. Now, in addition to it just being that easy to go from a substream to the subgraph, as long as you put in those entity changes into the tables, the syncing speed is where you really, really see a drastic improvement. Now, if we could get some nice indexers on this, if I publish it up, it would be even faster. But yeah, it's amazing how fast it is, and obviously that's one of the huge benefits with going from substream powered subgraph, a regular subgraph to a substream powered subgraph. And the ease of this really is that, it's going to take some work to get your substream built. If you're looking to just get regular events and not do any coding, obviously the substream in it, plus the graph deployment commands is going to take you less than 2 minutes, which is insane, right? We just went from substream to the subgraph in less than 2 minutes, automatic, like all code gen, which is awesome. So just showing you that process, I think is, will open up some eyes to how easy it really is to just go from a substream to subgraph, and hopefully get some more people involved in just developing substreams, because the transition is extremely easy. The one side that you're going to have to work through that, like I said, in my opinion, is one that is the biggest and highest learning curve, is dealing with the entities, right? Because the entity, the loading of an entity and the store access in a subgraph does not truly exist in the Substream side, in the Substreams world. You have to manually create that. It doesn't know that it outputted all these things. So like in a subgraph, it knows that this entity was emitted and stored, and you could easily access that. But on the Substream side, it's really just passed through. So there is no knowledge of this actually happening once it occurs. So if you really needed to do anything with these, you have to think and build out the store in that fashion so that you could go access it within the Substream and then say, hey, okay, what did it look like last time I wrote to it? Go get it and then re-emit it with those changes. So that's one thing to keep in mind. And, I'm sure things like that are going to improve over time. But, yeah, it's super, super easy to do those things. I wish I had a little bit more content to really go over, but it's so simple that I'm really at a loss here. So, I don't know where, if you want to open it up to some questions about this, we could.
Yeah, absolutely. Let's open it up, see if anyone has any questions. That's really awesome. I mean, I think it's a good overview. Like you said, it's simple, but that's like the beauty of it, right? It's simple and sweet.
Oh, yeah.
Yeah. And yes, you do make this look very easy, Mike says, which I would agree. You're really good at it. Any questions?
Yeah, I mean, if you're really trying to just go from, like, if you have a contract you're trying to index and you just want to get those events out into the graph ecosystem, all you need is a contract address and some command line arguments that are going to push up the data to the subgraph, and you're pretty much done. And you just inherently automatically just see the benefits of using a substream over the subgraph by just doing a small little exercise like this. So
very cool. Does anyone have any questions for Thomas here? Awesome. I guess I had a question. So that I'm sure there might be some viewers that tune in. And like the biggest thing I hear about substreams is the fact that it's, they're written in Rust. So Rust can have a little bit of a learning curve, especially if you're not used to like, more lower level programming. But Rust kind of has this, nice mix between lower and higher, which is interesting. So I think it appeals to a lot of people. But where would you recommend people start with, like getting a little bit deeper into Rust and kind of understanding it? I know there's like the implementation for the substreams is probably not super complicated, but like, yeah, I think people are just a little daunted at getting started. So where do you recommend people go? Do you have any recommendations?
I mean, me personally getting into substreams, I didn't really have a background on Rust. And I really just used the init, spun up the project, and then kind of started just tinkering around from there. Because it's all the stuff you would need to know is going to be there, then you could kind of reuse it, right? So if you're looking at how the events actually get, collected, you could kind of see it here, how it was done, right? And you could kind of be like, oh, okay, so we have some, a list of events, we have a block, we have receipts, so you could kind of work through those things and kind of tinker around with it. I mean, that's the best way I like to learn. It's really each their own. I know there's like a 30-minute like Rust crash course that's like really, really popular that I read over, and it'll help you in some areas. So I mean that's probably a good piece of documentation to look at. But really, if you're really looking like it's your first time and you're a little intimidated, I would use the substreams in it, pick a contract, and then kind of just start messing around with stuff. You'll start seeing how things are coded up in a way that's going to make you understand it a little bit better. And then also the docs itself. So if we go to, I use this a lot. So there's some things that you may not know even exist. So if we came into Substreams and I was talking about the store a lot, the documentation is great for you to just go through, and you can see all the structures that are in it and be like, oh, cool, I could, there's a big decimal store. Let me check that out. So going through those, even if we went to the entity changes, there's some stuff in here that I may have not even went over. Spell it right. Yeah, entity changes. Here we go. So we have everything, those the tables we were talking about are in here, and then the rows of the tables and things you could do with them. So we go into row, I think, see, you'll have the documentation on what is set do, what is set big into. So doing that research is really, really helpful as well. I love coming here. I always have this open. So it's something that I definitely rely heavy on. And I would definitely look into whatever, if you're working with Substreams, look into this. You'll find a lot of cool things that some people don't even know exist. It's like, oh, wow, I could, you may have just wrote up all this code and there's already like a preset function that already does it for you, So like for example, I didn't even know the set big int and set big decimal existed. So there I am converting it every single time from a string to a big int when I don't even have to do that. So things like that is where you could definitely gain knowledge, get some new ideas.
Cool. Thank you for that. Yeah, and James also left some comments there in chat. So anyone who wants to get started, check those out. Yeah, it was great. So last minute, anyone have some questions for Thomas or anyone else have questions just in general about the graph?
Here goes Paka. So he's the one that made me do this to begin with. He's the one that last time he said, hey, let's look at Substream power graphs.
Yeah, we'll give Paka a second.
He posted last time a link to the update to the graph node, which actually allows you to kind of take this a step further, which I wish I was a little bit more prepared to talk about. I just haven't had time to dive into it. Yep, here we go. See, there you go. I knew you were going to say it. We're saving. I'm just sprinkling these things out next time.
Little alpha.
Yeah. So. Alpha. Yeah, this is actually really, really great. It will help in some of the downfalls where I said, accessing the graph store is a problem, in Substreams. So what you could do here is, this is an example subgraph, and you could use the module outputs of the Substream modules you create and import them as a data source. So right now what we're doing is we're just simply going end to end within a Substream to get it to sync up to the graph. But you could, and maybe we'll do this in another iteration of this, but you have in the manifest here the data source Substreams, the package, and we have this module name of filter, and then you have the mappings, right? So handle block. This is a little different than what we currently have in the demo I just showed off. So you could take your Substream, so extract all the events you want from the Substream, and then take that protobuf definition of that event and use it as a data source in your subgraph itself and kind of just build. So get the speed advantage from a Substream, do exactly what I just did and just go get a contract, get all the events, and no graph out is even necessary in this case. So we don't have to worry about all those tables and stuff. And then in this mapping file, you'll see essentially bytes are coming in, and we as the data source rather than a block as we're used to. And you could say, okay, for this definition of block and receipts, which we have a type of, right? Decode the bytes that are coming in as that, and then use it as you normally would, right? You just do an event save on whatever whatever data you're importing. So all the modules you create in a Substream, you could build it there for the speed, and then bring it in here as bytes and just save it. So maybe we'll do something a little bit more detailed down the road. But this is something that's just like really, really exciting, because I feel like it will help bridge that gap with accessing the Subgraph store in a way. So
very cool, very cool. Yeah, it's going to be awesome, and we would love to have you on again to dive into that more if you're willing. So just let us know. Yeah, you did a great job today. Thank you so much for giving us the walkthrough. And yeah, does anyone have any more questions? Yeah, thank you, Thomas. That was really good. Great presentation as always.
You got it.
Cool. All right. Well, thank you everyone for coming on. Oh, you have something else?
Nope, I'm good.
Nope. Okay, cool. Yeah, thank you so much. Really good seeing all you guys. And yeah, we look forward to seeing you next week. And if you guys have anything you want to bring up, and I'll be hanging out here for a little bit longer. So just let me know. But otherwise, see you guys next week.
Yep. And just one more thing I wanted to add to, if anyone wants to reach out to me, I'm always on Discord. We're always at the BuildersDAO, very helpful. So I encourage everyone to get into Substream. So if you guys could think of anything after the call, feel free to reach out.